Hello everyone, welcome to the next tutorial. In this tutorial, we are going to discuss about the delta to star transformation for inductors and capacitors. Okay, so in the first case, we are going to discuss about delta to star transformation for your inductors. So as we know, the series and parallel combination of inductors are similar to that of the series and parallel combination of your resistors. Okay, so it means that the value of L1, okay, will be equal to, so the value of L1 will be equal to the product of the adjacent inductors which are connected in delta, which is LA, LB, divided by the sum of all these three inductors. So L1 will be equal to LA into LB upon LA plus LB plus LC, okay. Similarly, we can see that L2 will be equal to, so L2 will be equal to LB LC upon LA plus LB plus LC, okay. And L3 will be equal to, so L3 will be equal to LA LC upon LA plus LB plus LC, okay. So I hope it is clear. Similarly, for star to delta transformation of inductors, the expression will be much similar to the star to delta transformation of a resistor network, okay. So we can say that LA will be equal to L1 L2 plus L2 L3 plus L3 L1 over L2, okay. Similarly, LB will be equal to L1 L2 plus L2 L3 plus L3 L1 over L3, okay. And LC will be equal to L1 L2 plus L2 L3 plus L3 L1 over L1, okay. So I hope it is clear. So now let's discuss about star to delta conversion of your capacitors, okay. So as we know, the series parallel combination of capacitors behaves opposite to that of series or parallel combination of resistors, okay. So it means that the value of C1 will be equal to 1 upon C1 will be given as 1 upon CA into 1 upon CB over 1 upon CA plus 1 upon CB plus 1 upon CC, okay. So on simplifying it, we are getting the value of C1 to be equal to, C1 is equal to your CA CB plus CB CC plus CA CC over your CC, okay. Similarly, okay. So similarly, the value of C2 will be equal to CA CB plus CB CC plus CA CC over CA, and the value of C3 will be equal to, let's say CA CB plus CB CC plus CA CC is equal to delta, okay. So we can say that C3 will also be equal to delta over CB, okay. So I hope it is clear. So basically, a delta to star transformation in case of capacitor behaves similar to a star to delta transformation in case of your inductors or capacitors, okay. So the derivation of these formulas or expression are not so important from a competitive exam point of view, but we will use these formulas when we will solve various types of numerical problems, okay. So now let's take a special case, okay. Special case. Let's say the value of the capacitors CA, CB and CC are all equal. So the value of CA equal to CB equal to CC, and let us assume that is equal to C, okay. So by applying the above formulas, okay, we can say that the value of C1 will be equal to C2 will be equal to C3 will be equal to 3 times of C. Okay, so it means that whenever a delta system is converted into a star system, the value of the capacitors increases 3 times. Okay. So similarly, in case of star to delta transformation for capacitors, okay, so we can say that the value of CA, 1 upon CA will be equal to 1 upon C1 into 1 upon C2 plus 1 upon C2 into 1 upon C3 plus 1 upon C3 into 1 upon C1 divided by 1 upon C2. Okay. So on further solving it, we are getting the value of CA will be equal to C1 C3, okay, over C1 plus C2 plus C3. Okay. So I hope it is clear. Similarly, the value of CB will be equal to C1 C2 upon C1 plus C2 plus C3, and the value of CC will be equal to C2 C3 upon C1 plus C2 plus C3. Okay. So in a special case, when all the values of the capacitors, C1 equal to C2 equal to C3 equal to C, means all the value of the capacitors are same, it means that the value of CA will be equal to CB, will be equal to CC, will be equal to C by 3. Okay. So it means that the value of the capacitors decreases by 1/3 whenever a star connected system with equal capacitors is converted into its delta system. Okay. So I hope it is clear. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.